Okay, chat. I'm sorry about that. Had my audio routing configured incorrectly. So I'll start over. Hello, welcome. My name is Brian, and I'm gonna stream on some. I'm gonna hack on some Tiger Beetle tonight. Tiger Beetle is a financial database written in Zig, and I'm presently working on the Rust client library for it. We've got bindings for. We've got a client for other languages, including Node, Go, Java, Python's in the works, but not Rust yet. And so that's what I'm here to fix. We've been doing this for a few weeks, all on stream. So this whole project is going to be on stream front to back. Tiger Beetle, all the clients for Tiger Beetle are bindings to an underlying client library written in Zig called TB client. And that library exposes a CFFI. So that's what we're using. We're just writing a Rust library that binds to this TB client library. In the future, we may implement a pure Rust Tiger Beetle client because there's a bunch of inefficiencies involved in doing async Rust against the TB client library. And we could probably get better performance and also maybe more ergonomic compilation without having to link to this foreign library. But for the immediate future and for the next few weeks at least, it's just all going to be binding to some Zig code and creating a nice idiomatic Rust API around it. So let's go ahead and go to our code and see what we have going for tonight. And tonight's probably going to be pretty brief, but I have a pretty strong idea of what I want to accomplish. So last time we made huge progress. Yes. So last time we actually got one entire operation working in the Rust client. So we can look up accounts from the Rust client. And there are, I think, 6 operations total in Tiger Beetle. Operations are like queries, basically. So now that we've done one, we really have a pretty straightforward roadmap for doing the rest. So the next few episodes are just going to be implementing more operations probably. And tonight I'm going to try to do one. So I'm just writing in our notes here. I've been keeping track of what we've accomplished so far, just so when we go back, we can, and I have to summarize at the beginning of every stream what we've done. So I need to be able to remember what we've done. A big part of this project, the streaming project, is kind of just showing all the warts of developing software. So I'm trying to remember like all the wrong paths we've gone down as we do this. And I've made several mistakes so far, and I'm happy with that. So goal this time is to implement some other operation. And let me see. I think what we're going to have to do is, well, let's just catch up and remember what we had working last time. So I'm going to start up the server. And this server is for a database that already has an account. Wonder why I'm rebuilding right now. I don't think I've changed anything. So if we run the REPL, we should be able to say look up accounts for ID 1, I believe. Look up accounts. And there we have an account here with ID 1 and some data associated with it. Now, if we go to our example, this is our test program right here. This is just Scratch for just exercising the library. This program connects to the server, looks up account number 1, and then just prints whatever it gets. So I'm going to cargo run that and just see if this all still works, which it should. All right, so there's the proof. We can look up an account. And here's the function. Pretty much everything related to this account lookup is in this one method right here. And just for review, what we fundamentally are doing when we submit an operation to the TB client library is we're calling this TB client submit function with a packet that is crafted in a specific way for each operation. Hey, Steel Tormentor, welcome back. I'm glad to see you here. Just getting started. We're going to do try to implement one more op tonight. I'm just kind of reviewing where we are. So we submit a packet, and then the way TB client works is that TB client is running an IO event loop on some other thread. And so when we submit a packet, nothing happens immediately. Sometime in the future, we get a callback here on this onCompletion function. And this happens in another thread. And our callback, the way we're going to deal with it is we don't want to do anything in the other thread. We want to be on the event loop thread, the Rust event loop thread. So what we're trying to do as little as possible in our completion callback. You can see here we just grab a closure out of our packet, which is what this is. OnCompletion is a type def of a closure. And we just call that closure. And then up here, every single different type of op we implement is going to implement that closure and send a closure to that other thread. And then that is responsible for doing getting back to the original thread in a operation specific way. And when I say operation specific, I mean we have to do some casts that are using types that are specific to the operation. So we just cast a bunch of stuff back from raw pointers to Rust pointers, boxes, and then send. Remember, this callback right here is running on some thread. And then we send a message back to the main thread with all of our data. So this not processing anything here, just doing some casts and getting the data back to the original thread, which resumes right here after this await. So we submit, something happens on another thread, and then we wait for a message that work has been done. And we follow up with error handling, and this is operation-specific handling of the result. And if we recall from last time, there's a very gnarly cast right here. And this cast is just a cast from a buffer of bytes to a struct. In this case, the TB account T struct. And I don't really love that. There's so many casting from bytes to a struct is just filled with peril. Lots of potential undefined behavior. But this TB account type, and all the types involved in the client API are designed so that you can do that. But in the future, I might try to make this a little more type safe in some way. Maybe there's something off the shelf we can use from a crate, or maybe we can wrap it in a function that makes some asserts about alignment and Indianness, things like that. Anyway, that's where we are. We're going to implement one more. I'm thinking right now whether I want to create a Rust type here, because this right here, this is our API. We're returning this C type from our submit account lookup operation. And ultimately, we're not going to want to return a C type here. We're going to want to redefine this as a Rust type. But it's kind of busy work, so I think we're going to move on and just leave it for now. All right, so the next operation I think I want to work on here is creation of an account. Because if we can create an account and we can look up an account, then we have some testing we can do. And also, creation of an account is not as simple as looking up an account. There are other operations we could implement, like a transfer, lookup transfer, or transfer lookup. And that's almost the same, but it's not going to really teach us anything. So I'm going to go figure out what the other operations are. And let me adjust my monitoring again. I'm kind of screaming into my ears right now, annoying myself again. Okay, that's better. And I'm not really sure the best place to find the list of operations in Tiger Beetle, but I know that in the state machine, we can find information about operations. Oh, and I already have the buffer open right to it. All right, so here is a switch on the various Tiger Beetle operations. We've done lookup accounts. Create accounts is the one we're wanting. And this account type here is the same account type that we were just looking at when we returned lookup accounts. Tiger Beetle's data model is very simple. It's kind of nice that way. I'm curious if it stays simple, how long it stays simple. So we got to figure out what to do with create accounts. To do that, I think we're going to need to go look at our bindings again. TB client dot. Let's look at these C definitions. So client submit, there's probably a struct. I'm wondering, we have to submit some kind of payload when we create a account. And I'm wondering if that payload is the account we were just looking at. Let me go back to our state machine. Account. I'm just grabbing for account right now, seeing if I find anything interesting. And I don't think I am. Operation. Here's an enum of operations. Create accounts. Okay. Let's search for create accounts, actually. That might be more revealing. Okay, that's the same thing we're looking at. Result type. Okay. So this is the two pieces of information we needed, actually. Event type here is defining the data type that is the input to the operation. That's the account we're already familiar with. And the result is what we're going to get back from the server. And it's a create accounts result, which I've never seen before, but noted for a few minutes from now when we have to write this code, we need to figure out what a create accounts result is. So in our packet, our payload is just going to be an account, I think. Let's just go get started. This seems like it's going to be pretty straightforward. And for this, I'm going to probably have the same buffer open in both places. And am I going to copy and paste everything? I am going to copy paste everything. No, I'm not going to do that yet. We're going to go look at our inputs and outputs and create two new ones. And I'm going to put these in the same order they were listed in state machine. So create accounts is going to go first. Okay, this is account lookup. And this is create account. Is that create account multiple with an S? It is. Okay, well that's interesting. So what we have written so far is a lookup account, but within the state machine, it's lookup accounts multiple and create accounts multiple. And I am wondering why that is. I'm thinking that this has to do with batching, that to the client side, it looks like you're creating one account at a time or looking up one account at a time. But internal to TB client, there's a batching step where it'll pull many queries, requests, many operations into a single message to the server. So I'm thinking that's all just kind of transparent and I don't need to think about submitting multiple accounts in a create accounts operation. So hopefully that assumption is correct. So during this project, I've been working by just kind of like reading the Surface API mostly, and then like making educated assumptions about how it's supposed to work. And so far, that's been working for me, which says something about either the design of the Tiger Beetle client API or about the design of my brain, I guess. But it gives me the warm fuzzies about Tiger Beetle's design. It seems to work the way I assume it's going to work so far. All right, this is create account singular, and then this is not going to be an account. This is going to be we'll call it the field account, but it's going to be a TBC TB account T struct. And now that I'm seeing this, I'm guessing that every single one of these operation structs I've defined is going to have one field. So probably at some point in the future, this struct is going to disappear. This struct is going to disappear. This one might disappear too, just replaced with an option. But for another time. Right now, we're going to stick to our game plan. All right, so we submit an account. And interesting thing is that the account data structure is used in multiple contexts for different purposes. And the way the fields are supposed to be handled is different in different situations. Like when you create an account, let's go look at TB account, TB client, yeah, probably H, TB account T. So when you create a new account, a lot of this stuff you're probably not supposed to fill out. Like some of these are probably going to be reserved for the database. Like the ID, do you pick the ID? I think you probably do pick the ID. So we probably do fill that out. Probably these are supposed to be set to 0. Are they required to be set to 0? User data, that's whatever we want to do with it. Code and flags and timestamp. I'm sure timestamp is for the server. And probably we're supposed to set it to 0, but again, are we required to set it to 0? I don't know. But like when you retrieve an account, like you create an account, you don't do anything with these. They don't mean anything during account creation, but we're still reusing this data type. When you query for an account, the server will set all these as appropriate and return that to you. So this same data type is used in multiple contexts. Whereas in another system, you might have like a create account struct and an account query struct that have different types. And this is a very intentional design decision within Tiger Beetle for simplicity. Like the implementation matches the interface in a lot of ways. All right, let's get back to what I was doing. I forgot what I was doing, but we have create account operation and create account OK. And this is going to return something, but it's not going to be found, not found. Actually, it might be found and not found. No, that's not right. I'm kind of thinking about the error handling situation we're going to have when we implement this method, but let's not worry about it now. Let me make this a struct and no fields for now because I don't know what we have to do with this. Now let's go copy and paste this method. And again, we're going to maintain the same order as in the state machine. So somebody who's already familiar with the code base otherwise, when they look at this, they'll see everything listed in the same order that they're used to. It's going to be submit, create account. This is going to be create account operation and create account OK. This assert doesn't mean anything here. This completion message, this type on the completion method is the payload, which for us is going to be, for now, this is going to be a TB account T, because the payload for create account is an account. And then here's our callback. This is all the same. This payload as this. So here, all these things that I'm changing are like potential type parameters to a extracted function in the future, because we're not going to want to duplicate this stuff forever. This is TBC TB account T. And this, I think, is the same. TBC TB account T. That doesn't change. This doesn't change. That all looks right. Oh, this is going to be so easy. Account. Box new op account. That's right. So account is the field that contains our struct. And to get back to what I was saying before, you know, in creating an account, sorry, I'm highlighting the wrong thing. When we create an account, we don't need all these fields, right? We probably just need a few fields like the ID and some of the user data, things like that. So I'm thinking like, do we actually expose this full TB account structure? Which is kind of like the Tiger style thing to do. Or do we make another structure here that just exposes the fields that are meaningful to account creation? But for now, we're going to do it just the way we're doing it. All right, create account. We're fixing this again. This looks right. So here we box our payload, the account. And this we put the account into the data right there. And I'm thinking right now that this I'm going to call payload, because again, we're copying and pasting this implementation over and over. And eventually it's going to be abstracted, well, both extracted to its own function for the purposes of abstraction. So I'm kind of wanting to call this payload. Call this payload. And I'll go do that in the other implementation as well. Is that what I want to do? That payload has to be freed somewhere. Did I free that payload? Yes. I am not sure. Result. All right, what I'm thinking right now, Chad, is that all the boxes I create here, let me undo this payload stuff. All the boxes that I create here get turned into unsafe pointers and then turned back into boxes. So right here, we convert this callback into a unsafe pointer. Here we convert the payload into an unsafe pointer. And up here, here's where we get the payload back. Okay, gotcha. For a second, I was not seeing the code to convert the payload back to a Rust box, which would mean a leak, but it's right here, right there. Oh, and here we also call it payload. So makes even more sense to rename this account variable payload. I'm going to do that in both functions. And let's go look at where we are now. So here we create this packet. And just looking for any uses of that type that is different here. So this is a TBC, TB account T, and all the rest is the same. Submit it, that's the same. And then the callback doesn't change. Callback's up there. We pull the packet out, we pull the result out. Packet status error check is the same again. This is the like first level error handling that tells us whether the request, was submitted and came back successfully. And then this result. I'm going to guess here that, again, the result could just be empty. No result is probably going to mean the account was not found. But now is about the time to go. I'm going to comment this out. No, I'm going to leave this the way it is. I'm going to build this. But now's the time to go look up that other struct for the create account result. But let's get this building first. Account look okay, create account okay. So this is not account lookup okay. This is create account okay. This is create account okay. And yeah, before I took these variants out of the enum, but I'm going to put them back because I'm kind of feeling like this probably is a case for returning not found. And for the type here, I'm just going to put nil. Create account, okay. Found, expected, okay. 135. This is, comment that out. Okay. Let's go let's go back to the state machine. And the result type of a create account is create accounts result. I wonder if there's something like that with a name like that in tbclient.h. Create account. Oh, here's create account result. Okay, that's something. Is there a struct? There's a struct. Okay. So the result is going to be this. TB create accounts result T index and result. This result is certainly going to be that enum we just looked at. Index though. This seems to me like it has to do with the batching because you can you create multiple accounts at a time. Create multiple accounts at a time. And so this index will tell you, which one was created or which of the accounts in the batch the result is for. I'm just kind of wondering now whether this is, whether I'm responsible for creating multiple accounts at a time or not. I still feel like I'm not. But our API is only going to submit one create account operation at a time. So when we get the result back, it's this create accounts result struct, and this index field is going to be meaningless to us if it's the case that we don't have to deal with the batching. I'm really feeling like there's something I'm not understanding here. I'm just searching for create accounts. Create account without an S. Create accounts. Look up accounts. This is making me wonder whether, so in our packet, let's go find our packet. In our packet, there's a field that says the size of the data. And I'm wondering if the TB client uses this to figure out whether this data pointer is actually an array, and it uses the data size to figure out the size of that array. Because if you have the operation, you actually don't need to know. If you have the operation, you know the size of a single payload. So this data size would be redundant. But if this data is actually an array, then data size could be like, you could say times, number of elements. And then TB client could understand that, okay, this is actually not just one operation, it's a bunch of operations. And that really changes my worldview if that's the case. I'm kind of thinking that we'll continue this way and just do one operation per submission. But that's going to be a big monkey wrench if we have to figure out how to do multiple operations of the same type within a single packet. Because that'll change our API. It'll be like more like a slice of account operations here. Interesting. Yeah, that's interesting. And if this is, okay, I don't even want to think about that now. I want to continue the way we've been going and just assume we're going to create one account at a time. But I'm going to have to go take this away and think about it. Okay, so we submit our thing. And then down here, this is not a TB account. This is a TB, what was it? TB create. Create account result. TB create accounts result T. Okay. Yep, that makes sense. And this is not going to be not found. This is going to be maybe exists. Although I would expect this result. Yeah. Let's see. Let's think of the possible results here for create account. Linked event. I bet there's got to be one that's like ID exists. Yeah, TB create account exists. Okay. So that's already accounted for in the TB create account result. In that case, I am going to get rid of this enum. So this can succeed. This function can succeed, but still the creation would not succeed. You gotta, this result is only for like, if there's a networking error or some other kind of error. All right, create account OK is going to be a struct again, and it's going to contain pub result. That's going to be, for now, just a TBC TB create account result T. In the future, again, we can't just expose this C type to the REST API. But for now, that's what we're going to get. And this is, again, okay, here. If it's empty, then we're going to turn, I'm going to assume this is not going to be empty. We'll see, though. Because if it was, in the other case, for account lookup, the result was empty if the account wasn't found. But in this case, I'm going to assume that we get a result, always get a result for account creation. All right, so again, we're just going to do the same thing, TB create account result, and it's going to return result is account. So we're going to dereference this unsafe pointer to copy the account into the return value. Let's see if that builds. Create accounts result. TB create accounts result TB create accounts 26. Where is this? Oh, right there. And there's another one on 129. TB create accounts result. All right, let's commit that and just think for a minute. I think that's enough to actually go attempt to create an account. So let's just go ahead and do that. All right, again, here's our test program. And we need to create an account with account equals account ID equals 10. And it's going to become a pain really soon because we're not going to be able to create the same account over and over against our test database. But here we're going to say let result equals client dot submit create account. And the thing this takes is a create account operation. And we need to await that. And create account operation has a field called result. And inside that is pub use. I'm going to re-export the internal bindings API as TBC just for temporary use while I need to access these native definitions. So we need to pass it a TBC create account operation. Oh, that's what that is. TB account T. And this has a bunch of fields that are defined right. TB account T right here. And let's look at the Rust definition actually. TB client.rs. And ID is going to be the thing that we need to fill in. And probably everything else is going to be a 0. Complication here is this type doesn't define like a default or anything. So for now, we're just going to have to write all these zeros out by hand. Did I get this syntax right? Is this a colon here or an equals? Gotta be a colon. All right, zeros everywhere. And then I'll come back and think a little harder about whether these are all really supposed to be zeros. Yeah, looks like it. But for fun, we can put some data in the user data fields just to see that work. This field is wrong. This is called account. So we awaited that, and now we can print it. And then when we look it up, we want to look up that same account ID. Let's run it and see. Okay, it did not work. Some kind of assertion. Looks like it's probably the assertion about the size of our result type for this operation. Excuse me, Chad. I'm just getting a little late here. I'm thinking I might do like a regular stream sometime in the evening. Right now I'm just kind of streaming whenever I want to, but I know I need to have some kind of schedule. So I'm thinking like commit to like Wednesdays at 8 p.m. my time or something like that, which is, around this time. It's a little late. It's 10 p.m. here. All right, what didn't work here? Let's go look at that library. 75, line 75. Oh. Payload. Data size. Did I put the wrong data size? I did. So I didn't update this when I copy pasted. The data size is not the size of a 128. It's the size of a TB account T. Another assertion failure, 120, line 125. All right, so I thought this result, I guessed this result was going to be 128 bytes. Oh no, I guessed it was going to be 8 bytes, but it's actually 128 bytes. So this TB create accounts result T, why is this 128 bytes? What is this thing that was in the result? So I thought it was going to be this. I thought it was going to be one of these structs, but it was not one of these structs. What is the result of a create account? I mean, the fact that it's 128 bytes makes me think maybe the result is the account. We can go ahead and try that and see if that works. Because I believe the size of the account is 128 bytes. Yeah, so maybe it, interesting. I'm just going to go look at this create account T again. TB create account. T. Oh. Wait. TB create accounts T. Create accounts result T. This is only 8. That's what I thought. I thought it was going to be 8 bytes, but it's not 8 bytes. So when you create a count, the result is not a create accounts result T. I wonder if I should go read the TB client code or if I should just make a few more guesses and see if I'm right. Let's make one more guess. Let's see if this is returning a account. This is a TB account T, and the result is a TB account T. Inside of this is a TB account T. Doesn't feel right to me though. On 129, I didn't replace something. TB account T. And okay, interesting. ID 1. I created an account, and the result does look like an account, but it returned me ID 1. Remember, I was trying to create an account for ID 10. Let's go look at this real quick and make sure I didn't. Account ID 10, create an account. I bet I put the wrong op in this. I bet I put the wrong op in when I copy pasted. Perils of copy pasting, of course. Yeah, exactly. Exactly that. Let's blow away the changes we just made because they're wrong. Interesting, nothing crashed when I screwed up so bad. So when we are doing the create account, gotta set the operation to the create account. Create accounts. That's probably it. And is that everything? So how did I just figure that out? I was looking at the output here. I'm just wondering how I jumped to that conclusion, because that's definitely the problem. That's so weird. I did a lookup accounts accidentally with a very bogus payload, and I did get back ID 1. I don't even know how I figured that out like that. I just kind of realized that, like, seeing ID 1 there in the result was weird. What we were trying to do didn't have anything to do with ID 1. Let's try this again. Okay, so that looks like it did something. Our result was a 13. We can go look up the enum for that. TB create account result 13 is what we're looking for. I think this is our enum here. Ooh, this is tough to read. Oh, still tough to read, but it's this one. Ledger must not be 0. Okay, easy peasy. In our test program, we can set ledger to, we're going to make a variable for this. Now we got a result of 14. Code must not be 0. Okay, easy peasy. At least it's telling me what I'm doing wrong. That's a great sign. I don't know what code means. All right, another assertion failure. 125. This is our, okay, so when we succeeded, we did not get a result at all. Okay, so that's interesting. So Tiger Beetle is optimizing for the happy path here. Like if the account succeeds, it's not going to return anything about it. Let's see what we did in the other case. So if there's no result, that's, good. So again, we probably are going to want to make this an enum. We'll call this success, and here we'll call this error. And again, this is telling us all kinds of stuff about how we might change the API in the future. Like maybe this will not be a, maybe this will just use the standard result type here. But for now, we're just going to go where the code is telling us. And create account OK is again going to be an enum with success containing nothing and error containing this result T. And I did something wrong. What did I do? Invalid struct delimiters on function call arguments. That's a strange error. Let's go look at it. Line 135. I syntaxed wrong here. That's what I left that field name there. It says success doesn't exist. I must have typed it wrong. I did not type it wrong. It's right there. Create account OK. No success found for account lookup OK. Oh, this is create account OK, not account lookup OK. Create account OK. All right. So I got an error 21, almost certainly because that account already exists. But let's go look at it, what that error is anyway. 21. Error 21. Create account result. Oh, I don't see a 21 here. Create account result 22, 24. Well, that's interesting. Oh, there it is. Ooh, the formatting of this module. This module is auto-generated by BindGen. It's pretty tough to read. Account exists, 21. So if we go back to our test program and we pick a new account ID, this should all work correctly. Okay, so result of the creation was a success, and the lookup was found, and there's our user data that we set, our ledger, our code, and you can see that the server gave it a timestamp. Great. So that all basically went according to plan. The big problem, though, chat, that we've run into here is that it really appears that the client is expecting these payloads to support arrays of operations, not just a single operation at a time, which is going to have a big impact on our API. I mean, it's not a big deal, but we're going to have to rewrite all these methods again. So probably what we'll do next, and not tonight, I think, but we'll take this, we'll go back, and this submit account lookup method will write another one called submit account lookup 2, probably, or maybe, yeah, probably just 2. And this will instead be a slice. And we'll figure out how to make this work with multiple operations at a time. And just test that hypothesis that that's how it's supposed to work, that you can submit multiple operations in a single submit. I'm kind of wondering, though, because this account lookup, so I already remember now that I'm thinking about it, there are some operations that can be batched and some that can't. And I think account lookup can't, because if you look at the result type of account lookup, you either get no result or you get a result with the value of the account ID. But if we had an array of these, then this isn't enough information to figure out like which result corresponds to which index in the operations slice array. So that makes me think that this is probably a non-batchable operation, or an operation that supports only one operation at a time. Whereas this one, because you remember this create accounts result T, let's go back to our, let's go back to the C code. This includes an index field that you can use to figure out this is the result that corresponds to this original request. But then this raises another question to me. So what I'm assuming then is submit account lookup works with one account at a time, but submit create account works with up to some n number of accounts. But this also makes me wonder what the deal is with batching inside the client, because the client also contains a batch function that is internal to the client and not exposed to what we're doing here. So this ability to submit multiple create account requests in one message is a separate feature from the batching feature, I think. I'll have to maybe go do some doc reading or something to understand exactly what the distinction between these two features are. Because it seems like you could just have batching, the general purpose batching feature, be used to batch multiple single create account requests at a time. But that doesn't seem to be how this works. It seems like it wants you to submit multiple create account operations at once. But we'll test that tomorrow, or maybe the next day, maybe tomorrow. We'll see. Anyway, I think that's enough for tonight. I really appreciate you coming and hanging out with me and watching me get confused about how to implement this Rust client for Tiger Beetle. I'm going to be doing this same stream off and on, irregularly, but fairly frequently for the next few weeks, and maybe even longer. We'll see. until this thing is fully done, I'm going to stream all of it. At least that's what I'm claiming as of now. We'll see. We'll see how that lasts. But I really appreciate you coming and watching. I'll see you next time. Thanks a lot, guys.